Welcome to part 3 of a three-part series on expression of concentration, specifically looking at adjusting concentrations of various pharmaceutical products. Throughout the next few minutes, you should be able to calculate the amount of diluent and/or active ingredient needed to prepare a preparation of requested concentration using the concepts of Alligation Medial with 100% accuracy and without assistance. Calculate the resulting concentration of mixtures having combined or mixed products of similar ingredients. Previously, we looked at using ratio and proportion to alter product strength or product concentration. We also looked at how we can use CSVS equals CD, VD to alter product concentration. And now we will look at the use of alligation medial and alligation alternate to alter product concentration or determine product concentration. We'll start off with alligation medial. Now, alligation medial enables the effortless calculation of the weighted average or percentage strength for a mixture comprising two or more substances with known quantities and concentrations. Now, here to our first practice question. What is the percentage strength, volume in volume of alcohol in a mixture of 3000 ml of 40% alcohol, 1000 ml of 60% alcohol, and 1000 ml of 70% alcohol? So you can just look at what is happening here in terms of trying to visualize or put a visual image to what was mixed. So 40% alcohol and the volume 3000, 1000 ml and the concentration 60%, and another 1000 ml and the concentration 70%. So having those information, we have both the quantity that was added and we also have the concentration. Let's see what information we can use that to get here. So you have 5000 mils of alcohol in total, but do we know the concentration? Not yet. So this is what we're going to be working out throughout the next few minutes. And so for the first step, we're going to be expressing the percentage strength of each of the solution in the mixture as a decimal. So this is what you're going to be ending up with. So firstly, your 40% alcohol concentration, 40% when converted to a decimal is equal to 0.4, and so on and so forth for your 60 and 70%. Now, the next thing that we're going to be doing is to determine the amount of alcohol that is contained in each solution by multiplying the decimal fraction by the corresponding quantity that we got previously. So the whole purpose of this is to determine the pure alcohol or the active ingredient that we're interested in the mixture. So remember 40%, and when we converted that to decimal it was 0.4. Now in essence, when you look at what that 40% means, it really means 40 ml of pure alcohol contained in each 100 ml that you added to your mixture. So the amount of alcohol then that is contained in the 3000 ml, you can use ratio and proportion here and you will get 1200 ml of alcohol. You can go ahead and work the rest for the 0.6 and the 0.7 alcohol added to the mixture. Now the third thing that we will do is to determine the amount of alcohol that would be in the final mixture. So in terms of the amount of pure alcohol in each mixture, we calculated that to be 1,200 mils for preparation 1, the second one 600 and 700 for the third preparation. Now, in terms of that total, that's 2,500. Now recall what our definition of concentration is. We're looking at the amount of active substance per final volume or total volume of mixture. So if it is that you have 2,500 mils of pure active and that 2,500 mil is in 5,000 mil of final mixture, I think you should be able to actually put a mental picture to that one and be able to come up with the concentration here without even doing the calculation. But let's go ahead with the calculation and see what that is going to be like. So 2,500 mils of alcohol is contained in 5,000 mil of mixture. So in terms of working out that percentage strength, 100 mil will contain X amount of pure alcohol, and in this instance we're getting 50 mils. So what this means is that the final concentration of the mixture that you have would be 50% volume in volume. That is 50 mils of pure alcohol to every 100 mil of mixture. Any questions? Feel free to rewind or replay the recording. If it is that you're still having any challenges, feel free to reach out to me. Let's look at another example. So if the following solutions were mixed such that 200 mils of 40% alcohol, 500 ml of 90%, 95% alcohol, and 1000 ml non-alcoholic solution, what would be the percentage concentration of alcohol in the resulting mixture? So again, you can draw up your schema, look at what is happening in terms of what you added, and then you can work it from there. So 200 mil, 500 mil, 1000 mil, and in terms of that final volume of our mixture, we are supposed to be getting 1700 mil. Now, in terms of concentration here, you would notice that for 200 mils, the concentration is 40% as given in the statement. For the 500 mil, that's 95% as given in the statement. And then for the 1000 mil that was added, it says non-alcoholic solution, meaning 0% with regards to the concentration of alcohol in that stock that was added to the mixture. Now, recall that when we look in terms of concentration, we're looking at our active. And in this case, if it's alcohol that is our active, the non-alcoholic stock, of course, will have 0% assigned to it as the concentration. And so recall what our next step is. We want to convert those percentages to decimal and then take the product of those decimals to find the amount of pure alcohol that is in each of those stock that was added to the mixture. So once you work that out, this is what you're supposed to be getting in terms of your responses. And just take note here in terms of the amount of pure alcohol for the third stock that was added, the value here is a 0. Now, the next thing that you want to do is to determine what that pure volume of alcohol is in those stock that was added to the mixture. And so we'll take the product of the corresponding volume and the decimal that we worked out when we converted the percentage into decimal. So once you work that out, 80 mils of pure alcohol in the 200 ml preparation And then for the 500 ml preparation, the amount of alcohol that is in that is 475 mils. You take the sum of all of those and you'd get 555 mils in terms of the quantity of pure alcohol that is in the preparation. Again, just to point out, recall we came up with that 0.95 from converting 95% to decimal. So in essence, what we're looking at here is that for each 100 mil of that specific stock that we added to the mixture, 95 mils of it is pure alcohol, because that is what the 95% tells us. So in essence, we can of course calculate how much alcohol is contained in the 500 mil. Now, once you do that, you're going to be getting that response here of your 475. Now, in step 3, we'll determine the total amount of alcohol that is in the mixture. And again, alcohol would be considered or active in this case. The total amount is 555 mils. Now, once we have this information, we can go ahead using the definition for concentration and determine what the concentration of the mixture is. So we want to do the active over the total or final volume of the preparation. And in this case, the final volume of the mixture is 1700 mils. The amount of pure drug that we have, or API that we have, is 555 mils. And so once we look at that proportion, convert it to percentage using ratio and proportion, you should get 32.6 mils in terms of the amount of pure alcohol that is in each 100 ml of preparation. What does that signify? It means that the concentration of that mixture is 32.6% volume in volume. Just to note that Alligation Medial is mostly used for liquids, but of course sometimes we can actually use it for semi-solids and creams and ointments. The concepts is applied when you have different mixtures of different concentration of known amounts. So you need to know what the volume is that you're adding to the mixture. You also need to know what the concentration is of those stock that you're adding to the mixture. Once you have that two bit of information, you can of course go ahead and determine what the final concentration of the product is gonna be, because you know how much of each of the mixtures, or know the concentration of each of the mixture, as well as the volume of each of the mixture that was added to the preparation. Now, while concentration of each mixture is known, the concentration of the final product here is what we're really interested in. So yes, I know I did add 10% of one item, and then 5% of one item, and I added this quantity of the first item and that quantity of the first item. But really and truly, what is most useful in terms of information here is what the resulting concentration is that you will get when you mix those products. Now, when we look at alligation alternate, this is a mathematical technique employed to determine the quantity of different components or mixtures within, well, with known strengths or concentrations needed to create a desired product of specific strength and quantity. Now, it is important to note that in this method, the proportion in which each of the stocks must be mixed are initially unknown, and this is what we will set out to calculate. Now, let's take a look at our first example. Calculate the amount of 20% weight in weight zinc ointment and 14% weight in weight zinc ointment required to produce 60 grams of 16% weight in weight of zinc ointment. Now, our first step is to identify the concentration and amount of the final product that we want to make up. So here we need to prepare 60 grams, and the concentration in this case should be 16% weight in weight. Secondly, we're going to identify the concentration of the components or mixtures available to prepare this product. So what do we have in this case as our stock? We have available 20% weight in weight zinc ointment and 14% weight in weight zinc ointment. Now, note the proportions of these ingredients. So you must know this information to be able to move on. You have to also be able to characterize them correctly to ensure that you, of course, get the correct concentration or outcome. Now, in step 3, we're going to calculate the proportions or parts of the 20% zinc ointment and the parts of 14% zinc ointment that is needed. So we're going to set up a flow diagram looking something more like this. Usually you put your higher concentration at the top, starting on the left, and then you have your lower concentration, usually down to the bottom at the left of the screen. What you want should be the center of your flow diagram. So your 16%, which is the concentration you're aiming for, of course, is going to be right there. And we're going to work in a sort of a diagonal, crisscross, and over the top fashion. Now, we're going to take the difference of the concentration of what we need and the concentration of what we have for both ingredients. So the first thing that we have here is 14%, and once you take the difference of that, you're going to end up with 16 minus 14, and that is 2% or 2 parts. All right, and I will be using those interchangeably as I go throughout. Now, again, going diagonally. So notice with your first, your diagonal goes upward, and in terms of the readout, will also tell you a little later in terms of how you interpret those. Now for your 20%, how much of it we're going to be using, you take the difference of that and you're supposed to get 20 minus 16, that's 4 parts. Now, why we went from down to up in terms of that diagonal fashion, the response that you're getting here is telling you that you should be using 2 parts of your 20%, and then for the 20% we went downward diagonally, and that is telling you that you're going to be using 4 parts of your 14%. Now, in terms of combining those, so 2 parts of the 20% ointment plus 4 parts of the 14% ointment, and those two, once you add them up, you are supposed to be getting 6 parts or 6 grams. So 2 parts of 20% plus 4 parts of 14%, that is equal to 6 parts in total. Now, the 6 parts are equal to the total amount of the preparation to be made, and that is 60 grams. So in this case, the 6 parts is a whole, and what does that mean in relationship to the product that you're making? Your 6 parts is equal to your 60 grams. So 6 parts is equivalent to 60 grams. So we will use this information now to calculate the amounts of the 20% zinc ointment and the 14% zinc ointment that we need to prepare the product of 16% concentration and final volume of 60 grams. Now, if 6 parts is equivalent to 60 parts of the preparation, so we're talking about the whole here again, how much will we need to add into this product when we look at the two parts of 20%. So we can simply set up a proportion here, and in terms of this proportion, 2 parts out of 6 parts, which is the whole, and you multiply that by the 60 gram, which is the final volume that you want, and that you will get the amount of 20% zinc oxide ointment that you should be adding to the preparation. Similarly, again, 6 parts is equivalent to the whole, which is 60 gram. And recall, we wanted 4 parts of it to be the 14%. So in this case, your 4 out of 6 multiplied by the whole, which is 6 grams, should give you the quantity of 14% zinc oxide ointment to be added to the preparation. So once you work those out, you should get 20 grams of your 20% and 40 grams of your 20%. So recall that we said your 6 parts is equivalent to your whole, which is 60 grams, and that is the product. Now, once you are finished with your computations, you need to, of course, make sure that all of those add up to give you the whole in terms of the preparation that you want to make. So in this case, 20 grams of your 20%, 40 grams of your 14%. And once you take the sum of those, you should be getting 60 gram. And this is what your new formula would look like. And in terms of your formula name, just recall you set out for 16% weight in weight zinc oxide ointment. So that's your formula name. And in terms of how you would combine the ingredients, you have that listed there in the new formula. This method can also be applied to liquids as well. Let's take a look. Now you have an example here to determine the amounts of 95% volume in volume alcohol solution and water needed to prepare 225 mils of 70% volume in volume alcohol solution. So we want to identify the concentration and amount of the final product that we want to make up. And in this case, you want to prepare 225 mils of alcohol, and the concentration must be 70% volume in volume. So that is what we want. The second thing is to identify what we have on hand. And what we have available is a 95% alcohol solution, and we also have water. Now, note that the amount or proportion of these ingredients, again, you must know what they are in order to be able to move on. Now, when you look at step 3 in terms of what we're going to be doing here, we'll calculate the proportion or parts of the alcohol solution and the water that we need. Now, again, setting up your flow, the center here will be what we want, which is the concentration that we will get with the resulting product, and that is 70%. And in terms of the two stocks that we have working with, you have alcohol 95% and you also have 0%. All right, so recall with regards to the definition for concentration, we look with respect to the active ingredient that we're discussing. And if you look at water in this example again, there is no active ingredient in the water or no alcohol in the water. So as a result, the concentration that is assigned to it is 0%. We will still do our computation in a diagonal fashion going upward, and in terms of the difference between the strength that we want and our lowest strength, you have 70 minus 0, and that is 70 parts. And then for the 95% going downward, we have 95 minus 70 giving us 25 parts. So here we have, again, relation going horizontally. At the top here, you have your 70 parts of 95% alcohol, and at the base here you have your 25 parts of water or 0% alcohol. In terms of what those total will look like here, 70 parts, 25 parts, and you have the stocks listed there as well. Now, when we look at step 4, here we calculate the total parts of the 95% and the water from the proportion that we worked out earlier. So here, 70, 25, and that total is 95 parts. Now remember, what we set out to make is 225 mils of alcohol. So with respect to that 225 ml final volume of alcohol, here we're saying the 95 parts are equal to 225 mils. So we can now go ahead and, of course, determine how much of each of the stock we're supposed to be adding per volume or by parts to the mixture to make up 225 mils of 70%. Now we'll calculate the amounts here, again still using the proportion. So for our 95 parts being equal to our 225 mil, in terms of what we calculated earlier, 70 parts of our 95%, once you set up that proportion for it, so 70 out of the 95 multiplied by 225 mils, and that will give you the number of mils of alcohol that need 95% alcohol that should be added to the mixture. And then for the water, that's 25 parts. So 25 parts out of 95 parts multiplied by the final volume of the preparation, 225 mils, and that will give you the amount of water that is to be added to the preparation, 59.8 mils of water. Now, again, you want to ensure that all the parts contributed by each adds up to the final amount that was requested, which is 225 mils. So in this case, once you add the two volumes that you calculated, you should get the sum 225 mils. And this is what your new formula for your 70% alcohol volume in volume will look like. So alcohol 95%, volume in volume solution, and that is 165.8 mils. And the amount of water that will be added is 59.2 mils. Just to point out here that the stocks or the lots that are used to prepare the mixture of known concentration and amount must have concentration that is greater and lesser than the requested concentration. What does that mean? If it is that you want to make a product that has a concentration of 16%, you cannot combine 14% and 10% in any way to give you 16%. And so when you are looking at the request that you have before you, you must determine that your concentration falls between the two stock concentrations that you have. So if it is that you want 16%, then you might need to get a stock with a higher concentration, and then you can use another stock that has, say, a lower concentration, may it be 14% or 10%, whichever the case is. Now, alligation alternate is quite versatile, and with this you can mix as much as 3, sometimes even 4 lots of mixtures to obtain a specific concentration and amount of product requested. Now, you could mix something such as, say, 14%, 10%, and 20%. zinc oxide ointment to obtain a 16% zinc oxide product, which may be requested. Let's look at how we would approach this. Now, for this case, we're going to be taking or approaching this in two stages again, similarly to what we've been doing. So what is it that we want? And here we're going to take two of our concentrations, one from the lower end of the requested concentration and the higher of the highest of the three stock concentrations that we are provided with. Again, we're going to be going diagonally upward and diagonally downward, and look at what your responses are in terms of the number of parts. So here we will be combining 6 parts of 10% with 4 parts of 20%. But this is not all. Remember, we have a third concentration, and this must also be used in making our product. Now, what are we going to do with this information? We're going to set up another one. Again, your concentration at the center of what you're doing here. That's your desired concentration. And then we'll take, again, the highest and the other of the two lower concentration that was not previously used. So before we use 10%, now this time we will use the 14%. We'll go again in our diagonal fashion and we'll work out what those are. And in terms of our readout, again, similar to what we have been doing previously. So here, 4 parts of your 14% along with 2 parts of your 16%. Now, in terms of what is happening here, so from part A, we had 6 parts of 20% ointment and 4 parts of 10% ointment. And then from the second part, we had 2 parts of your 20% ointment and 4 parts of your 14%. You must add up all of these to give you the total number of parts. Now, once you exceed 2 in terms of the number of stock that you are mixing with Alligation alternate, you will realize here that the total number of parts equals the concentration of the product that you want to make up. So if it is that when you work it out, you are getting a number of parts that is less than the final concentration that you want, then something is awry. You need to double check your computations. And so now in this case, of course, you can characterize all of these in terms of the proportion contributed by the stock, each of the stock that you used. So we had 3 stocks here. You had 14%, 20%, and 10%. How much was contributed by your 14%? And that here is 4 parts of your 14%. And in terms of the amount contributed by your 20%, this was in 2 portions. So it's 6 parts plus the 2 parts that was worked out in part B here. And you'd get a total of 8 parts there for your 20%. And then in terms of your 10%, how many parts? You have 4 parts, and that is as given here, 4 parts of your 10% ointment. And so with Alligation alternate, we just need to be aware that you can use it for both liquids and semi-solids, such as your creams, ointments, and gels, etc. And in terms of the applying the concept, you must know the concentration of the ingredients that you are mixing, and you must know the concentration of the product that you want after mixing those ingredients. Now, in terms of where alligation becomes helpful, alligation alternate becomes helpful, of course, it tells you what proportion or what quantity, in what quantities you need to mix those stock that you have to get the desired concentration. You must also Bear in mind that whatever you want in terms of your desired concentration, you must have a concentration in your stock that is greater and one concentration, at least one concentration that is less than the desired concentration that you want to compound.